Alright, let's look at solving the log equation. And remember, when you're solving for log equations, you have to reject any values that does not belong to the domain of your original logs. And you also want to give your answer an exact solution. So we're trying to solve log base of 9 of 10 minus log base 9 of x equals 1. Before we can even solve for our variable x, we have to condense our logs. So remember, subtraction comes from the quotient rule, so subtraction comes from division. So if I can put this back together, let me see. So if I put this back together, we're going to end up with log base 9, your top is 10, and your bottom is x, equals to 1. So now we cannot solve log equations like this. We must change it to exponential form. So we have a base of 9 raised to the power of 1 equals to your answer of 10 over x. And from here, now we should be able to solve for x. X is right now on the bottom, so I need to get it to the top. I need to get rid of x on the denominator, so the opposite will be to multiply by x. So that's how we end up with 9x equals 10. We're trying to solve for x, so I'm going to divide by 9 to both sides, and that's how I get x equals 10 over 9. So what does it mean to reject any values that are not in the domain? Remember, we're not allowed to take log of negative numbers. A log of a negative number will give you an error. Therefore, you see here we end up with positive 10 over 9. So if we were to plug this in back in here, it's not going to give me logs of anything negative, so I don't have to worry about 10 over 9 not being in the domain. So now let's do this one, which will require a little bit more work, right? So we have log of x plus 1 equals log of 42. We're trying to solve for a variable x, so we start by condensing. In this case, we have addition. Addition comes from the product rule, so that means it comes from multiplication. So we can condense this by taking log of x times x plus 1 equals to log of 42. And in this case, we have log x times x plus 1 equals log of 42. So both of our sides, we got them to be a single log, so you can apply the square root property. And this is the square root property of logs. And that says if you can get them to be the same log on each side, we can simply worry about x times x plus 1 equals 42. And now you can see here I have to distribute my x, so I end up with x squared plus x equals 42. Because we have an x squared, that means we're going to end up having to factor. So I need to move my 42 to the side. So I end up with x squared plus x minus 42 equals to 0. Now that it's equal to 0, now we can actually apply the AC method. So I have 1 times negative 42 equals negative 42. We're looking for factors that will add up to 1. So I know factors of 42, 7 and 6. I can make the smaller one be negative, and they add up to our b, which is 1. Because our a is 1, because our a value is 1, I know I can factor this into x plus 7 and x minus 6. So now that it's factor, we set each factor equal to 0. So I end up with x equals negative 7 and x equals positive 6. But you have to go back and check for your values to work. Look, if we were to plug in log of negative 7, right? Because if we were to plug in negative 7 for x, we will end up with log of negative 7. We cannot take logs of a negative number. It's not within our domain. So I know I cannot use this solution. So I can only use x equals 6.